Hello, everyone. Here we go. Chapter 9 and Chapter 10, test review. Be looking at all of these if you're looking to learn some of the content or very much of the content that we're doing in a particular course related directly to this or in many other aspects of different courses if you're not familiar with some of the content. Okay, I've gone into that already. Let's look at some of this. They want us to solve. And as we said, like I said, this is the Chapter 9 and Chapter 10 test review. There it is. And let's go for it. Number 1, solve for A when you're given this. Well, tell you what, why don't you subtract C on each side? Add a negative C or subtract C. You get AB is D minus C. When you get to here, well, solve for A, they say, right? Solve for A, get A by itself, divide by B. And there you go. You got that one. For this one right here, solve for X. I'm going to factor an X out of here. Then I'm just going to divide. Once I get to here, I'm going to divide by the quantity A plus B. And that'll end it. What you have is, for this particular place, you have X equals C over the quantity A plus B. So we got that. Solve for R. Number of ways you could go here. I'd probably take R over S plus T equals W. I would take each side and multiply by S. Just to get rid of the fractions. And we've gone down this path before in one way or another. S coming across, you've got S R over S, ST, SW. Here's R, here's ST, here's SW. Solve for R. Subtract ST on each side. That works. Because S is common to both, it might be a little more efficient, looks a little better. The aesthetics are better if you go like that. And again, I'll check these real quick with the answer key that you're also going to have scrolling in front of you. But we're looking at something like that. Okay? They want you to solve for Q on this one. So what we have here is solve for Q. You got to kind of get Q out of there. And there's a number of ways you could kind of play this, I guess. Number of ways you could go here, I guess you could say. I'll tell you what, I'm going to take the P and distribute it. PQ, PR equals S. So distribute the P all the way across here, you get to here. Let me subtract PR on each side. That's out of there. PQ equals S minus PR. At that point, you're trying to solve for Q, as we said. Divide by P on each side. Again, there's a number of ways this can be written. Let's see how the answer key wants to go. I probably would stop right here. But that's not necessarily the only place you could stop. There's many wrong answers, and sometimes there's at least a few good answers that are valid. Whereas, of course, there's many ways to get something wrong. But there's maybe a couple ways at least, or more, to write the right answer. I'm going to say that. I mean, there's other, I mean, I don't know, you could almost argue. Let me just kind of go there for now. P goes into S. That's SP. P goes into PR R number of times. This will also work. I wouldn't doubt if this is actually the one in the answer key. Either one's probably fine. You can argue it either way, but I wouldn't doubt if that's in there. Okay? That'd be about it, though. I mean, as far as to look at, one or the other on that. They want you to solve for x right here for number 5. Here's adding the opposite's not a bad move. You can say a lot of stuff here. You can, a lot of ways to go, actually. You could add a2x on each side. That goes. Add a2x on each side. You got a2x plus a3. You could subtract, I want you to solve for x. You could subtract a3 on each side because you're trying to solve for x. This is not the only way to do it. Certainly not. Divide by a2 on each side. That goes. You get x equals a1 minus a3 over a2. And here you go. Let's see if they're agreeing with us here. They should be. For number 1, we're in agreement. Yes, for number 1, we're in agreement. For number 2, we're in agreement. For number 3, right. It can go, let's see where we had gone, actually. You could, they actually stayed here for number 3. I just think it's aesthetically better to go here. But I don't think we're going to make a big deal out of that. One or the other, I think, would be accepted. They had gone here. So this is where they had gone. I went here. I think they're both fine. 4, they actually went where I thought they'd go. They went right here. But at the same time, they also accepted this. Okay, that sounds good to me. For 5, they got x equals a1 minus a3. They got x equals a1 minus a3, that quantity divided by a2. That's fine. Spot on. We're good. All right, guys. Those are the first 5. Let's move on. We pause this real quick and get the other stuff set up pretty good. Okay, guys, let's continue. I've put some new problems up here. We went 1 through 5 earlier. Now we're doing 6 through 10. Problems 1 through 5 we did earlier. Now problems 6 through 10 we do now. All pertaining to Chapter 9 and 10 test review. Let's see what we can do here. They want us to solve for this one, number 6. They want us to solve for b sub 2. Got to get b sub 2 by itself. Tell you what, when we're looking at this, there's always a number of ways to go. Let's go this way. Let's multiply. Let's multiply by 2 on each side. This is a single entity once it's in parentheses. When you are multiplying two entities, they are two factors in a sense. You cannot distribute across a multiplication. You can distribute across an addition, but to do that, you got to either go to this over here and leave this one alone, or hit this one and leave that alone. You can't, or you can actually multiply this all out, have straight out addition, then you can distribute. But you cannot distribute the 2 to the h over 2 and to that entire quantity. We've already mentioned something like that earlier. Okay? Watch out. Distribution only happens when there's straight out addition and or subtraction going on. And you can distribute a division, you can distribute a multiplication if there's addition and or subtraction present. Absolutely. But when there's multiplication and or division going on only, you only hit the division once to one of the items, to one of the factors. You only hit the division to one of the factors, not to both. When it's straight out multiplication and or division going on, you will not distribute the multiplication or division. You'll only hit one of the items if you choose to do so. When there's addition and or subtraction going on, you can distribute it. You cannot go and hit this and all that. You can hit all that, then distribute inside of here, but don't touch h over 2. Or you can hit h over 2 and don't touch that. Okay, we've kind of gone there. We can talk more about this in class if we need to do so. So there's not going to be you're not going to distribute this because these are two factors multiplied together. Forget this addition in here. Pretend it's just one chunk of a number and another one chunk of a number. You're not going to distribute. Hit the 2 here, bam, bam, it's gone. You got 2a equals h b1 plus b2. You can now distribute this thing over here. You could have done it earlier, and then from there distribute it again. That's something else. I'll tell you what, I just want to get b2 for an answer here. I'll tell you what I'm going to do. I'm going to divide by h on each side. And you got b1 plus b2 equals 2a over h. Subtract b1 on each side. That's out of there. This is probably where they're going. I don't think they're, I mean, there's other ways to write this, and they're pretty strong ways to write it, but this is probably the best way to write it. So I think this is where they've gone to actually do this. So that's number 6. Solve for v. What I do with this one would be, let's get v squared by itself at least. Why don't you multiply by gr on each side. You get wv squared equals grf. Divide by w on each side. You get v squared is grf w. It's a large W, so I want to kind of retain some level of honesty with the actual numbers that are present. If two things are equal, they remain equal. If you do the same thing on each side, I got to get v squared to become v. I'm going to square root each side, and that's your answer. So let's see how that plays out, you guys. The square root of v squared is v. The square root of this is whatever it is that it's going to be. got it. We're here. We got F equals all this for D. How are you going to do it? A lot of ways to go here. They want you to find D. Well, let's do it. Let's multiply by D squared on each side. That goes. We got D squared F equals K M1 M2. Nothing else there, actually. After that whole song and dance, it's just K M1 M2. Divide by F. And you get D squared equals divide by F on each side. You got to here. Square root each side. D equals the square root of K M1 M2 over F. All right, guys, running out of room a little bit here. I guess when I write these down to pre-plan the whole thing, pre-plan the whole process to actually get the answers here. See how it's looking, but here we go. We got that. Let's go to 9. Let's see what I can pull off here. That one might take a bit. So let me erase a couple of these. Let me just do some erasing here, I think. I think it might be a good idea at this point. Let me go to 9. I mean, that was what we just finished here was number 8. So that was number 8. We're going to do 9 and 10 right now. Let me just erase these so you guys have them. Okay, guys, we've got this right here. Let's solve for R sub 2. So a little, we got subscripts going on all over the place with this one. So initially looks maybe a little bit intimidating. Let's solve for R sub 2. Okay, well, I'll tell you what. Maybe it's a little easier than we think it is. Let's subtract D times R1. Let's subtract D times R1 on each side. And what we end up getting is RT minus D R1 for that one. So for this right here, RT minus DR1 is RT minus DR1. That's out of there, and this comes here. So you're here. You know, you're not done. Certainly not done, but you're here. Now, this is not a bad place to be, because to solve for R2, you just divide by this quantity on each side, and you're done. So for number 9, this whole thing ends by taking this and dividing by the quantity D plus R1 on each side. And there you go. Yeah, looks pretty good. Looks pretty good. Okay, guys. Get a little more chalk here. Solve for M. Again, it looks just like problem number 9. Just like problem number 9, it looks a little intimidating at first glance. And look how fast problem number 9 was solved. This problem number 10 is the same way. At first glance, a little intimidating, but you know what? All that I have to do is get the M on top over here by itself. Get the M by itself. What do you say just multiply by M on each side and see what happens? So what you got is you got P, W, multiplied by M on each side. There you go. You've got M times P. You've got a capital P. You got me, guys. I got to try to be kind of faithful with this thing. That's a small p, so yeah, that's fine. That'll work. You multiply by m on each side. This cancels. You got W divide by p on each side, or multiply by 1 over p. Divide by p or multiply by 1 over p. Either way, p just goes right here. M equals W times the quantity W times the quantity x minus y, P times the quantity s minus t. Interesting point. Remember, guys, dividing, the way this, just to not, I don't want to, beat this up too badly here or anything, but if I say to you, when we had, for this one, when we had MP, remember, we got it down to P equals, P equals W times the quantity x minus y over the quantity s minus t. If you multiply, forgive me, there was an m right here from the get-go. So we had it down to here. Before the m was put on there, we were given given right off the bat that P was equal to W times the quantity x minus y over M times the quantity S minus T. That's what we were given from the beginning. We multiplied by M on each side, and we got to here. So if you're going to have the MP and the W S minus T right here, yeah, that's fine. What you can do is, from right here, you can take a couple different paths. You can take the path here of saying, okay, let me take MP equals W x minus y over, again, the M that was here got canceled out. Let me divide, and we were solving, as we said, we solved for M. Let me divide by P on each side. Right. Well, dividing by P is the same as multiplying by the reciprocal of P. And that brings you to well, that, when you do this right here, that's what P equals. That right there is, forgive me, that right there is what M equals. M is going to be equal to, if you cancel here, you've got the M. M equals this. That'll work. Dividing by P is the same as dividing by P over 1. In other words, if I were to divide by P and divide by P here, P is P over 1. A fraction divided by another fraction is the first fraction left alone multiplied by the reciprocal of the second fraction doing the dividing. A fraction divided by another fraction is the first fraction, the one that's being divided, left alone, right here left alone, multiplied by the reciprocal, which is that, multiplied by the reciprocal of the second fraction doing the dividing. That gets us here. That was the move I made here. I think people saw that anyway, or at least many saw that anyway, but it's not, maybe not something that's very obvious all the time, you guys, to look at. So again, look at the subtleties, look at the rules. If you know how to do the rules, you're going to have the mathematical dexterity to get through everything that you need to get through. All right, so that gets us all the way through 10. Let me set up some other problems here. Okay, guys, let's continue. Again, they're asking, same kind of concepts here. It's a little different dynamic here. For capital F, solve for capital F, given what you have right here. Number of ways this can be done. Again, the easiest way is somehow get all the F's together. Well, it's actually, at the end of the day, no matter what technique you use, you got to get all the F's together and have them over to one side and have everything else somewhere else. And then from there, look for some kind of division or something. Well, I'll tell you what, if I look at this, I can do something like that. Go for it, and you got this. Is that true? Yeah, well, here's your h. The FG stays. Distribute the t, you get down to here. Okay. More comments on this? Well, yeah, I mean, I think it's pretty easy move at this point, guys, to be honest with you. Subtract t over there. You were already subtracting t. Why don't you just add t on each side? That's out of there. You got h plus t equals fg plus ft. Here's a real big move to make. Let's put this stuff, let's kind of like, it doesn't matter which way you report it. Let's have this stuff over to the left. Take all this and take an f out of all this. And what you have is the h plus t is this. Tell you what, I'll make that, I'll put parentheses around that. It's not a big deal. Once you get to here, guys, once you get to there, you're basically done. You're really close to done. I mean, you take G, here you do have to take the whole quantity. It's a whole piece of a number. F equals quantity h plus t over the quantity g plus t. Yeah, that's it. There it is. Solve for b. Not too bad, not too difficult to do. You can do it a couple ways. The easiest way to do it is just get the b squared over to one side, add b squared on each side, and you get b squared plus c squared. Subtract c squared on each side. You get a squared minus c squared equals b squared. B squared equals a squared minus c squared. Square root both sides. The square root of b squared is b. And the square root of this is whatever it is. But at least written out, there it is. Okay, so it's looking pretty good. We feel pretty good about this, guys, up to that point. They're saying here, now again, these are, you're looking at, you're trying to solve this. Given this equation, give me the x comma y associated with if the x is equal to negative 2. Well, if the x is equal to negative 2, go 4 minus 2, x is negative 2. Leave this for now. 4 is 4. 2 times negative 2 is negative 4. 2 times negative 2 is negative 4. Minus a negative 4 is plus 4. 4 plus 4 equal to 8. If the y is equal to 1, so that's that. If the y, this is the y value now, x comma y. So if the y is equal to 1, so we had x equals negative 2 right here, and we got y. It spit out the y that we wanted. If y is equal to 1, it's going to spit out the x that we want. But let's go. We got this right here. We got y equals 4 minus 2x. They're telling us that y is equal to 1. Minus 2x is plus a negative 2x. subtract 4 on each side. This is negative 3. This is out of there. This is negative 2x. So what we got here is negative 2x. Negative 2x equals negative 3. X is 3/2, or 1.5. So that's pretty neat stuff. And again, we could check this, guys, in case I'm overlooking something. I don't think that I am, but okay. So what we had was, here's where you're using this for all of this. You're filling in the blank, and that's an 8. You were doing all this stuff that you had to do for that. Once again, you're working with this guy. Minus 2x. And you got the 3/2 right here, doing everything that you had to do. Okay, let's see what we got here, guys. What we're looking at is something like this. There's a lot of ways you can play this. This is more or less a general format. There's like a standard form and a general form. This is more or less along the lines of a general form. Slope-intercept form is often the way they like to write linear equations in 2 variables. Y equals mx plus b, it kind of gives you a nice look if you can get it to have that look. Well, how do you get it to have that look from the beginning? Well, you can take 2x minus y equals 12. Minus 3y is plus negative 2x. Let's divide by negative 3 on the side. That's out of there. Negative, now you distribute. There's addition and or subtraction going on. You will distribute the division or multiplication. You only hit it once. You go here or you go there. You don't go to both. But when there's addition and or subtraction going on, you go to both places. Negative 2 divided by negative 3 is positive 2/3. There's your x, keep it. 12 divided by negative 3 is negative 4. Now, nobody asked you to even go down this path, but this is not a bad path to go down. This is not a bad path to go down. Plus a negative 4. So this is the slope-intercept form. This is y, that's y. The 2/3 is the m, that's the slope. The negative 4 is the y-intercept. Well, okay, I guess we killed a couple birds with one stone. The y-intercept at this point, is going to be that negative 4. It's going to be a value of 0, negative 4. The y value, the x value is 0. Where does the line intersect the y-axis when y equals, where does the line intersect the y-axis when x equals 0? It's 0, negative 4. So this right here will do it. B, the x-intercept. There's a number of ways you can kind of play this, guys. Let me probably erase at this point. Some of this stuff is pretty lengthy, so let me go this way. It's not too bad, but right, guys. As far as other things that we can say, y equals 2/3 x plus a negative 4. There's a lot of ways we could play this. Since we worked hard to get to where we got, might as well use what we got. So look, there's a lot here, guys. Let me try to. There's a lot already been written, I guess, and so like I said, the y-intercept is always 0, comma b. The b was the negative 4 right here. This is the slope. Nobody's asking you for that, but for the record, that's the slope. And this is slope-intercept form, y equals mx plus b form. We took this, manipulated it, and got this equation more or less general form, more or less standard form. We took this equation in some kind of standard form that it was in and made it slope-intercept form. We basically did all the monkey business that we did, guys, and we solved for y. As I said, it was mostly, just, I guess it perhaps bears repeating. Minus 2y is, minus 3y rather. So what we got is minus 3y is plus a negative 3y. Subtract 2x on each side. Divide by negative 3 on each side. And we got that. And that's we did that earlier. It just bears repeating. This is a very popular way to write the equation of a line when you're talking about a line in two-dimensional space. When you're talking about two variables, two-dimensional space, x and a y, slope-intercept form is what we just did. We took it from a more or less standard form and made it slope-intercept form. These are mathematically identical equations. When they're graphed, the lines are exactly the same. The equations are identical. One's in a different form than the other. This form, slope-intercept form, is very popular, very, very good to use it, I guess you could say. The x-intercept is when the y is equal to 0. And that'll be your x-intercept to find that. So you got to solve for x to get that. Well, when y is equal to 0, this is all that you have to do at that point. Add a positive 4 on each side. Okay, so you got it down to here. You just put, for the x-intercept, that implies that y is equal to 0. That implies that y is equal to 0. So you take the standard, you take the slope-intercept form, you put y equals 0, and you solve for x to find the x-intercept, because it implies that y equals 0. Y equals 0, put it right here, add a positive 4 on each side. Okay. At this point, 2/3 x equals 4, multiplied by 3 on each side. Divide by 2 on each side. Again, this stuff is usually easier done than it is explained. This thing right here would become x equals 6, y equals 0. So x equals 0, y equals negative 4, x equals 6, y equals 0. And that's just what the x-intercept would be right here. Well, then if you end up taking these two, and to graph it, there's a number of ways you can graph it. You can set up a t-chart. You can take the slope-intercept form and start plugging in values. Since you got these two intercepts, 0, negative 4, and 6 comma 0. 1, 2, 3, 4, 5, 6. This is 6 comma 0. 1, 2, 3, 4. This is 0 comma negative 4. 2 points determine a line. There's your equation of the line. You could have also set up a t-chart and, put, for this guy, put 0 in for x. Oh, whoa, it spells out that. Put, for the heck of it, let's say you guessed it, put 6 in for x. 3 goes into 6 twice. 2 times 2 is 0. Forgive me. Put 6 into here. 6 right here. 3 goes into 6 twice. 2 times 2 is 4. 4 and negative 4 is 0. So you could have gotten them just by plugging in here in the t-chart. You could have kept going. You could have said, well, I don't know. I'll put a 3 in here. Put a 3 in here. The 3's cancel. You got 2 plus negative 4. That's negative 2. I could put a 9 in here. 3 goes into 9 3 times. 3 times 2 is 6. 6 and negative 4 is 2. These work too. Are they on there? Well, I just told you, just saw 2 of them. 6 comma 0 and 4 comma negative, forgive me, 0 comma negative 4. 0 comma negative 4 and 6 comma 0. 0 comma negative 4 and 6 comma 0. 3 comma negative 2. 1, 2, 3. Negative 2 goes down to about here. Yeah, sure looks like it's there. 9 comma 2. This is 6, 7, 8, 9. Comes up to here. That's about 2. That's not, this is 9 comma 2. This is 3 comma negative 2, et cetera, et cetera. They would theoretically, if you could graph it perfectly, you'll be able to see that all those points, any 2 points that solve the equation of the line, the slope-intercept form equation of the line, any 2 of those points, any point that solves the slope-intercept equation of the line, this particular line in this particular instance, whatever values of x comma y work, these are ordered pairs. They're x comma y. It's 0 comma negative 4. It's 6 comma 0. It's 3 comma negative 2. It's 9 comma 2. Except these are all, so any ordered pair that satisfies the equation of the particular line under consideration, any ordered pair that satisfies that equation lies on the line. Graph them and you will see indeed that they all line up. And that'll help us later when we're doing some stuff. Okay, let me take a pause on this and then set up some stuff for you to look at. Or maybe not. Before we do, let me see if I can maybe see a couple other things here really quickly. For 15, they say write the equation of the line below. You got something looking like this, and like I said, you guys have access to this in your notes if you're in my particular class, and at the very end it's scrolling anyway. 1, 2, 3. 1, 2, 3. 3 over. Anytime it's a horizontal line, there's a constant altitude. There's a constant y. Anytime there's a vertical line, as we have right here, it's going to be a constant value of x. The x that solves this is x equals negative 3. Okay, let's just check this stuff real quick, guys. It should be good. So if you ever want to talk about a horizontal line, y equals some value, some constant. The altitude is constant, so you have a horizontal line. If the distance sideways is constant, then the x is a constant, whatever that may happen to be, whatever value you have here. If it was over here, it'd be x equals positive 3. So if the sideways direction is constant, then the x value is constant. If the altitude is constant, then y is constant. It almost at first glance comes across as counterintuitive. Say, that thing's vertical. There's all these y values. It's got to be some kind of y equation. No, it's all the points are at a constant distance away from the y-axis. That distance is a constant x value for this. All these things up here, that must be something associated with x. Well, no, that's a constant altitude. The x's are constantly changing, but the altitude doesn't change. Here, the y's are constantly changing, but the sideways displacement from a perpendicular distance from the y-axis, that doesn't change. So that gets us there. Let's just quickly verify this. We should be okay, guys. I don't want to just, well, okay, I just ended up erasing a whole bunch of stuff too. So I'm confident it's all fine, guys. It should be all right when we're looking at it. Let me kind of look as I remember all this stuff. Yeah, it's all of it's good. Yeah, and like I said, the stuff is all there for us. Yeah, everything's there. Again, I'd like to check this stuff. I'll look at it. I mean, I'm sure it's fine. It's what we had said for that one. Give me just 1 second, folks, just to kind of make sure we got this thing okay. Right. It looks pretty good, guys. I'll try to take a closer look next time before I start erasing some of the stuff, but it looks okay. And again, we do have the answers at the very end of the video. Going to be scrolling, so we should be all right. Okay, sounds good. We got through 15. When we start this thing up again, we'll get to 16 onwards and take this thing to the very end. Okay, everyone, let's go toward the end of this particular review test. For number 16, they're saying write the slope of the line below. Write the slope of the line below. When a line slopes upward to the left, it has a negative slope. When it slopes upward to the right, it has a positive slope. If it's a horizontal line, it has 0 slope. And if it's a vertical line, the slope approaches infinity. But we call it undefined. The slope of a line is the rise over the run. It's the delta y over the delta x, in a sense. It is the change in the y, the change in the y's over the change in the x's, but you have to be consistent. It doesn't matter, but it's basically if you're given any 2 points on the line, x sub 2, y sub 2, and x sub 1, y sub 1. If you're given any 2 points on a line, you call them whatever you want to call them, but you got to go in order. x2 minus x1 on the bottom, y2 minus y1 on the top. You can't mix and match them. Once you've chosen, you could even go You could even go, you could put y1 right here minus y2, but then you got to have x1 right here minus x2. The order of the subscripts has to be identical for numerator and denominator alike. You can choose whatever way you want to talk about it, but let's talk about it now. This right here, well, these are interesting. This is the y-intercept. This is the x-intercept. The x-intercept is a location or a number 1.5 or 3/2 at a height 0. That's what this one is. This one right here is not going anywhere left or right, but vertically it goes to here. That's the y-intercept is this. The x-intercept is that. You call them whatever you want to call them. I'll tell you what. I'll call this x sub 2, y sub 2. You call this x sub 1, y sub 1. And let's go. Y sub 2 is 3. Y sub 1 is 0. So, yeah, absolutely. Y sub 1 is 3. Y sub 1 is 0. Forgive me. Y sub 2 is 3. Y sub 1 is 0. X sub 2 is 0. So let's see what we got here. X sub 2 is 0. Y sub 2 is 3. X sub 1 is 3/2. Y sub 1 is 0. So, yeah, you're doing this in the order you're supposed to do it. Y sub 2, 3, Y sub 1, 0. Y sub 2, 3, Y sub 1, 0. X sub 2, 0. X sub 1, 3/2. When you do this, you got 3 divided by negative 3/2. Now, I said if it slopes upward to the left, there'll be a negative slope. Let's do this. A fraction divided by another fraction is the first fraction, 3 we'll call 3 over 1, multiplied by the reciprocal of the second fraction doing the dividing. Multiplied by the reciprocal of the second fraction doing the dividing. And there it is. There's your slope. The slope how are you going to do this? Okay, that's the way you're going to do it. Regarding some of the other stuff that we're doing here, doesn't matter who you call what, but once you do it, you're stuck. I'll call this x sub 1, y sub 1. I'll call this x sub 2, y. I just as easily could have called the first one x sub 2, y sub 2, and the second one x sub 1, y sub 1. I could have called this one x sub 2, y sub 2, and this one x sub 1, y sub 1. It doesn't matter. But once you make the move, you got to stay consistent. It's the change in the y's. Even here, it doesn't matter the order in which you subtract them, as long as you consistently subtract them. If the subscript 2 is in front, it stays in front for both numerator and denominator. If the subscript 1 was going to be put in front, like this, that's fine, but the subscript 1's got to be in front with the other. They both equal m. They'll both give you the right answer. Guaranteed. Guaranteed. So let's deal with it. You know, we called the names that we wanted to call, and we'll figure out what we want to do, guys, regarding some of this stuff. So you look at it, and you say, what's going on here? Well, okay, let's see what's going on. Y sub 2 is negative 2. Y sub 1 is negative 4. Y sub 2 is negative 2. Y sub 1 is negative 4. X sub 2 is 5. X sub 1 is negative 3. Let's make sure we got that right. Y sub 2, see what we got here. Y sub 2 is negative 2. Y sub 1 is negative 4. X sub 2 is 5. X sub 1 is negative 3. Looks pretty good to me. Plus 4. Minus a minus is plus. You got plus 4 and a negative 2. That's 2. Minus a minus is plus. 5 and 3 is 8. It's 1/4. It's 1/4. And that's the answer. That's what the slope is going to be. It's a positive slope, 1/4. It's not a very radically big positive slope, but it's a positive slope. Kind of interesting. If you were to graph this, you look at negative 3 comma negative 4, negative 1, negative 2, negative 3, 1, 2, 3, 4, negative 3 comma negative 4, and the other one's 5 comma negative 2, 1, 2, 3, 4, 5, negative 2 down here. Well, it's not a great big slope, as we said, but it is sloping upward to the right. It is sloping upward to the right, you guys, and that's indicative of a positive slope. So that's pretty interesting in that regard. For number 18, write the following equation in slope-intercept form. State the slope and y-intercept. That's not a bad move for us to make, and it's not a difficult move for us to make, you guys. Reason for that is we've already done it. We've already done something like this. I would take this and I would say, okay, 3x minus 6y equals 10. Minus 6, there's a lot of ways to go here, guys. Tell you what, let's do something a little different, give us a little more practice. 3x minus 6y equals 10. 3x minus 6y equals 10. Minus 6y is plus a negative 6y. Add a negative 3x on each side. That's out of there. Negative 6y equals negative 3x plus 10. There it is. It's a pretty important move. Get to here. Divide by negative 6 on each side. That's negative over negative 6. That's 10 over negative 6. This comes out to negative divided by negative is positive. 3 over 6 is a half. This right here, 2 times 5 is 10. 2 times negative 3 is negative 6. Negative 5/3. That is the equation of the line in slope-intercept form. The equation of the line in slope-intercept form. We said that this, if you put a 0 right here, that whole thing becomes 0, and you got y equals negative 5/3. Y equals negative 5/3 is the y-intercept. The y-intercept is b equals negative 5/3. Therefore, it's 0 comma 5/3. So here's your y-intercept. B is equal to negative 5/3. They usually write it like this. And we got that right there. Not too bad. Not too bad. For 19, they're saying complete the solution chart and graph the following function. Well, it's the t-chart we're talking about, guys. They're putting down 0, negative 1, 2, negative 3. Let's go. It's the quantity squared. It's always like this, guys. It's 2 times the quantity squared. So a negative number squared is always going to be a positive answer. So watch out. The only thing getting squared is this right here. But when it's getting squared, there's a negative number in there. When it's getting squared, when there's a negative number in there, it's going to be a positive answer. Then you multiply by 2 at the end. 2x squared. Put a 0 here. Don't go 2 times x and then square it. 2 times x and then square it is 4x squared. This is mathematically a reality that can occur, and you get this for an answer. That has nothing to do with that. The only thing getting squared here, guys, is the x. And if you square a negative number, you still get a positive answer at the end of all that, is what I've been trying to say. All right, so put a 0 right here. 0 squared is 0. Put a 0 right here. 0 squared is 0 times 2 is 0. Put a negative 1 right here. The quantity negative 1 squared is negative 1 times negative 1. Negative 1 times negative 1 is 1. 1 times 2 is 2. Put a 2 here. 2 squared is 4. 4 times 2 is 8. Put a negative 3 here. The quantity negative 3 is the quantity negative 3 squared is negative 3 times negative 3, which is 9. 9 times 2 is 18. We've got, there it is, the x comma y. Got 0 comma 0, negative 1 comma 2, 2 comma 8, negative 1 comma 2, 1, 2. 2 comma 8, 1, 2, 3, 4, 5, 6, 7, 8. Negative 3 comma 18. Negative 1, negative 2, negative 3. 18 somewhere out here, and of course I drew this wonderfully. Well, you guys get the picture. This thing's going to do something like this. It's a parabola, and it's looking like that. That's why I probably should have drew this a lot lower, right? Maybe done the scales a little differently. But you can see it is a graph that is symmetric both east and west. Does not cross over into negative realm because you have no negative numbers that are attained in mathematics that you're doing. Okay? So that's of interest. That's 19. 20. They are saying the function g of x equals 24 over the quantity x minus 2 is not defined for one value of x. What is it? You're not allowed to have division by 0. If x minus 2 are equal to 0, you're going to have a problem. Add 2 on each side. At x equals 2, g of x is undefined. At x equals 2, g of x is undefined. For this one right here, g of x equals 2x plus 3. If x is equal to negative 2, whatever you put inside the parentheses is what you substitute in for x. So you put this right here. 2 times negative 2, negative 4. Negative 1 is the answer. In this particular instance, that's the answer for this particular value of x that's in there. G of negative 2 is negative 1. Okay, that was 21, you guys. How would you evaluate this? Well, wherever you see here's where the x is. Wherever you see something inside where the x normally is, you will substitute that value where the x normally is, you will substitute it for x in the function. They call this thing the argument. What's between the two parentheses here, that's the argument. Whatever you put in the argument, you're going to put in for x. So f of t, instead of x, you're putting a t there, and you got this. F of t plus 1, this whole thing is now your new x. It's your new x. You put it right here. Multiply it out. 3 times t is 3t. 3 times 1 is 3. Interesting. So what we have here is we've got this, and we've got this. So if you're going to subtract the two, as you're being asked to do, if you're going to subtract the two, you've got 3t minus 3t plus 3. That's interesting. You can distribute, you can do a lot of stuff here. I mean, 3t is 3t. The minus can distribute in a sense. These two, when you subtract them, are 0. You got negative 3 for an answer at the end of all. And that's 22. All right, guys, let me just do a quick check on this stuff. We should be okay, but just in case there's any issue. From 16 onwards. From 16 onwards. 16, the slope is negative 2. 17, yeah, right. 16, the slope is negative 2. 17, the slope is 1/4. 18, it's y equals 1/2 x plus negative 5/3, or y equals 1/2 x minus 5/3, same thing. The y-intercept is 0, negative 5/3. We got that. The slope is a half. Did they even ask us for the slope? They may have. If they did, I've already kind of mentioned this sort of stuff, but the slope is indeed a half. They may have asked that and I just simply missed it. Slope is a half regarding that. So that's 18. 19, again, it's the parabolic equation looking just fine. 20, the answer is 2. You're not allowed to have 2 there. Why? Because 2 minus 2 is 0. 24 divided by 0 is undefined. This function is defined for all real numbers in the universe of real numbers, except for the number 2. All real numbers work for this except for the number which is the number 2, except for the real number 2. 2 is the only one where this is not defined, because 2 minus 2 would be 0. 21. Right, at the end of the day, we got what we got here, guys. At the end of the day, this guy comes out to, here's your final answer, g of negative 2. Negative 2 is equal to negative 1. We got it. 22. Right, at the end of the day, that came out to negative 3. Okay, sounds good. There is a last question to be asked here. Let me just erase one of these and we'll take it from there. What is the domain of the following function? Okay, so For 23, what is the domain, the place where the function is defined? There is no value of x that will create a problem for you if x is greater than or equal to 0. If x is a negative number, you get negative answers underneath that radical sign. And the real numbers, there is no square root of a negative number found in the real numbers. So it wouldn't work for us. Domain is the set of all x, such that x is greater than or equal to 0. They kind of wrote it out a little less rigorously. All real numbers greater than or equal to 0. In other words, it just means all real numbers greater than or equal to 0. All real numbers greater than or equal to 0. That's all they're saying, guys, right here. Fantastic. We got through. I mean, I paused it a couple times, but it's all going to be unified, all put together. So you'll see how the blackboards are kind of changing. It's a little more time efficient that way when we do this. So once again, everyone, thank you for your time. This was Tech Math 1, Chapters 9 and 10, Test Review. And I hope it helped, and we'll see you soon.